A tiny moon of Saturn, barely wider than the length of England, is shooting geysers of ocean water hundreds of kilometers into space. Enceladus is one of Saturn's many moons, measuring only about 500 kilometers across. Its surface is covered in ice so bright and reflective that it reflects almost 100% of sunlight. This makes Enceladus one of the most reflective objects in the entire solar system. In 2005, NASA's Cassini spacecraft discovered massive plumes of water vapor erupting from the moon's south pole. These geysers shoot icy particles and water vapor at speeds of over 1,000 kilometers per hour. The plumes originate from long fractures near the South Pole nicknamed tiger stripes due to their striped appearance. Scientists determined the geysers are fed by a massive liquid water ocean hidden beneath the moon's icy crust. This ocean is estimated to be about 10 kilometers deep, covering the entire moon beneath tens of kilometers of ice. Tidal forces from Saturn's massive gravity flex and stretch Enceladus, generating heat that keeps the ocean liquid. This process, called tidal heating, is the same mechanism that keeps other icy moons warm despite their distance from the Sun. Cassini flew directly through the plumes multiple times, sampling their composition with onboard instruments. The plumes contain water vapor, ice particles, salt, and organic molecules including simple carbon compounds. Scientists also detected molecular hydrogen in the plumes, a potential sign of chemical reactions at the ocean floor. This hydrogen may result from hydrothermal vents, similar to those found deep in Earth's oceans. On Earth, hydrothermal vents host thriving ecosystems that survive entirely without sunlight, using chemical energy instead. This discovery makes Enceladus one of the most promising places in the solar system to search for alien life. Unlike Mars, which may have had liquid water only in its ancient past, Enceladus has liquid water right now. The ocean has likely existed for a very long time, potentially providing a stable environment for life to develop. Scientists have also found silica nanoparticles in the plumes, evidence of hot water reacting with rock deep inside the moon. These particles suggest hydrothermal activity requiring temperatures of at least 90 degrees Celsius at the seafloor. Enceladus essentially offers scientists free samples of an alien ocean, without needing to drill through kilometers of ice. The material ejected from the geysers eventually forms Saturn's diffuse E-ring, one of the planet's faint outer rings. This means every time you see Saturn's rings, part of what you're seeing may have come from this tiny ocean moon. Cassini's mission ended in 2017 when the spacecraft was deliberately crashed into Saturn to protect Enceladus from contamination. Scientists wanted to prevent any possibility of Earth microbes accidentally contaminating a potentially habitable moon. This decision reflects how seriously the scientific community takes the possibility of life on Enceladus. NASA and other space agencies have proposed future missions specifically designed to search for life in the plumes. A dedicated Enceladus orbiter or lander could directly analyze plume material for signs of biological activity. Such a mission would search for amino acids, complex organic molecules, or other potential biosignatures. The technical challenge lies in designing instruments sensitive enough to detect life without carrying contamination from Earth. Enceladus is not the only ocean world discovered by spacecraft. Jupiter's moon Europa has a similar hidden ocean. Scientists now believe ocean worlds may be far more common throughout the solar system than previously imagined. Some models suggest even distant objects in the Kuiper belt could harbor subsurface liquid water oceans. This has fundamentally changed how scientists define the habitable zone, the region where life might exist. Traditionally, habitability was thought to require distance from a star similar to Earth's distance from the Sun. But tidal heating shows that moons far from the Sun can still maintain warm, liquid, potentially life-supporting oceans. This dramatically increases the number of potentially habitable worlds not just in our solar system, but across the galaxy. Enceladus reminds scientists that some of the most promising places to search for life are hidden beneath ice, not on visible surfaces. The moon's gravity is so weak that a person could jump and reach escape velocity, floating off into space. Despite its tiny size, Enceladus has become one of the most scientifically important objects in the entire solar system. Every new data point from Cassini's flybys continues to be analyzed by scientists searching for further clues. The Moon exemplifies how the search for alien life may not require traveling to distant star systems at all. It might simply require looking more carefully at the icy, overlooked moons orbiting our own giant planets. Enceladus proves that even the smallest, coldest, most unassuming moons can hide oceans of liquid water, and perhaps, hidden somewhere in that ancient darkness, they hide life as well.